So one of the things that some of our students are confused with is this, right? So we have written probability of x greater than equal to mu plus k sigma. This is with respect to Chebyshev's inequality, right? So they're confused how I arrived from one formula to other formula. So I'll just explain this quickly for you, right? Mu minus k sigma. This probability is less than equal to 1 by k square is what is the typical form. Let's call this equation 1, right? So now let's write equation 2, which is probability mu minus k sigma less than x less than mu plus k sigma. Okay, so I have in the video for Chebyshev's inequality, I have gone from this to this, and some people are confused how I made that jump, right? So let me elaborate and simply explain it to you, right? So if you take this as a random variable x, right? Let's assume this is random variable x. What does this mean? This means, okay, so let's assume this is my mu, right? This is, let's say, mu minus k sigma. Let's assume this is mu plus k sigma. Okay, let's assume x is a continuous random variable, which means it can take, let's assume x is a continuous random variable, which means it can take values from minus infinity to plus infinity, right? What is the first probability saying? The first probability is saying, right, that the probability, okay, of the values falling in this region less than, right, x less than equal to mu minus k sigma, which means this whole region, right? This whole region, right? And or x greater than equal to mu plus k sigma, which means this region, right? This whole region, right? So the probability that your random variable x lies from this value towards minus infinity, this whole region or this whole region, the probability that your random variable, what does this say? It says your probability that x is greater than equal to mu plus k sigma or x is less than equal to mu minus k sigma, which means this whole region, the probability that x lies in this region or in this region is less than equal to 1 by k square. That's equation 1. Now, what happens to the probability of x lying in this region now? This region. If the probability of x lying in this region plus this region, let's assume just for simplicity, right? The probability of x lying in this region plus this region is, let's say, 0.2. Okay, both these orange regions. Then what is the probability of x lying in this region? 1 minus 0.2, right? Because these two are called mutually exclusive events, which is a mathematical way of saying that x can either lie in this interval or x may not lie in this interval. There are only two options, right? X can't lie elsewhere because x lies between minus infinity and plus infinity. Either x can be less than mu minus k sigma, this whole region, or x can be greater than this. This is one possibility, or x can lie within this region. Very simple, right? So if to write this, so let's again write this, right? What is this equivalent to? This is nothing but, okay, let's write it. The probability of mu minus k sigma less than x less than mu plus k sigma, right? Which is this LHS, right? What is this? This is 1 minus this. What is this? This is nothing but 1 minus this. So let's write this. This is equal to 1 minus this probability, right? 1 minus probability of x greater than equal to mu plus k sigma or x less than equal to mu minus k sigma, right? And we know, so this equality is simple, right? Because if the probability of this whole region, this region and this region is 0.2, the probability of the random variable falling in this region will be 1 minus 0.2. Very, very simple probability. Either you get heads or tails, right? When you throw a coin toss. Similarly, either x lies in this region or x lies outside that region. There are only two possibilities here. And that's why the sum of both these probabilities should be 1. Now, we know that this value is less than equal to 1 by k square, right? So this value we know is less than equal to 1 by k square. We know that, right? So now can I write it this way? Can I write it as we know that this value is less than equal to 1 minus, it's less than equal to 1 by k square, right? Now what happens, look at this. Now this is one probability. Let's call this as A, just for simplicity, okay? Let's call this as B, okay? So we have A equals to 1 minus B, okay? I'm writing this whole thing as A, this whole thing I'm writing it as B. Now we know that B is less than equal to 1 by k square. We know this, right? Now what happens? Now we know that this B is less than equal to 1 by k square. Now, if I subtract 1 by k square from both sides, okay, or if I add 1 minus, instead of subtracting, see, this value is less than 1 by k square, which means A will be greater than 1 minus 1 by k square. Simple. So let's assume, again, I'll show it to simply, right? Let's assume 1 by k square equals to 0.1. Let. What does this mean? This means B is less than equal to 0.1. If B is less than equal to 0.1, remember, if B is less than equal to 0.1, then what can we say about A? We can say A should be greater than equal to, right, 0.9 or greater than 0.9, because the maximum value I'll subtract from 1 here is 0.1, because B cannot be greater than 0.1. A will always be greater than 0.9, because the relationship between A and B is this. Now if I know that B is less than equal to 0.1, which is equal to 1 by k square, let's say, let's just say, then I know that A will always be greater than equal to 0.9, which is equal to 1 minus 1 by k square, right? I hope this logic is clear, right? This is simple inequalities that probably we learned in high school, right? So by using this logic, we arrive at this equation. The fundamental reason is that x can lie either in this interval, or x can lie outside that interval. That's how I arrived from equation 1 to equation 2. I hope this is clear. And I try to explain this with a simple example, right? If A equals to 1 minus B, and if we know that B is less than equal to some value, let's say 0.1, we know that A will be greater than 1 minus that small value, or B, right? A minus 1 by k square, A minus 0.9. This is simple inequalities, nothing very fancy here. But the fundamental fact is this thing. This is how I arrived from equation 1 to equation 2. I hope this is clarified now.